Hi, I'm an old guy and I do maths. Today we have a rather interesting problem, but I guess I would say that. We have been asked to find out a number of things about the object that you see on this XY plane. So we are told that this is a square. We are given two coordinates and we are asked to find a number of things about this, principally what these points are and what the equations of these lines might be. Coincidentally, I'm sure we can find the area, and that should solve a number of mysteries. So let's get to work. So we have a coordinate 0, 4 and 3, 0, and these form up with this line a right angle triangle, and so we can deduce the length of this line using Pythagoras. So we'll go ahead and do that. Just create some room so you can see what I'm doing. We have 3 squared plus 4 squared is going to equal this line squared. We'll call that c squared. So that is 9 plus 16, and that equals 25, and 25 is c squared, so c will be 5. This is 5 units. So that is 5. We'll just stick that there. This is a square, so that is 5. So this whole thing is 25 units squared. Well, that's our area to these points. Now, what do we know? We know that the gradient of this line is found by using the rise over the run. And the rise is 4, the run is 3. This line has a negative gradient because it slopes that way. This line has a positive gradient sloping that way, and because this is a square, which I might just emphasize here, these lines are perpendicular to each other. So if this has a gradient of rise over run, 4 over 3, negative 4 on 3, then this line has a gradient of 3 on 4. Now, we arrive at that because the gradient of a perpendicular line is given by this little formula here, negative 1 over the gradient of the original. So as this is negative, this will be positive, as you can see, and we invert the fraction. So the answer is that that is 3 over 4. Now to find a, what we do is we travel 4 in this direction, that's the run, and we go up 3 in this direction. This is not the only way of doing it, but it's a pretty good way of doing it. So if this point is 4 and we have increased that by 3, this will be 7, and we have moved 4 in this direction, so this is 4, 7. Now let's try the same here. We go across 4 from 3, which is going to give us 7, and we go up 3, which is going to give us 3. So that point there is 7, 3. Well, that's some of this problem done. Now let's get to these lines. Let's start here. This is the simplest one to do. We have the gradient for this. Y is equal to negative 4 on 3 x, and we have the y-intercept plus 5. So that's 1. That's done. Now, This one here, 2, we can do fairly quickly as well, because we have the gradient. It equals 3 over 4. And, sorry, that should be 4. I don't know what I was thinking. I must have been thinking about this line. The y-intercept is 4, not 5. So, scratch the initial mistaken thought there. The y-intercept is 4. So we have equations for lines 1 and 2. For line 3, we have the gradient. Y is equal to negative 4 on 3x plus c. We don't know what c is. It's a way up somewhere on the y-axis. How do we find it? Well, we have some points. We know that this line passes through this point and this point. It doesn't really matter which one you use. I'm going to use this. So I'm going to replace these values with the points in this ordered pair here. So y is 7. That is equal to negative 4 on 3 times 4 plus c. So negative 4 times 4 is negative 16 over 3. And 7 is equal to negative 16 over 3 plus c. Right, well, what is 16 over 3? 3 goes into 16 5 times with 1 remainder, so it is 5 1/4. So 7 plus 5 and 1/3. I'm getting my numbers wrong a lot today. I don't know what it is. Apologies. 5 1/3. We go from there to finding c. So that equals c. Now, 7 plus 5 1/3 is 7 and 5 is 12. This is 12 1/3 equals c. So our equation is y equals negative 4 on 3x plus 12 1/3. You could write that as, if you wanted to, 37 over 3, if you like the symmetry of fractions. So that is that, 12 1/3, 37 over 3. Now, on this crowded piece of paper, we're going to find, so we have found 3, that is number 3. We are going to find 4. Now, 4 we know has a gradient of 3 over 4. So y is equal to 3 on 4x plus c, and we will take a nice easy point like this. 0, so that's our y coordinate, is equal to 3 on 4 times 3 plus c. So we're looking for c, and that means that 0 is equal to 9 over 4 plus c. So c is going to equal negative 9 on 4, and our equation is going to be y equals 3 on 4x minus 9 on 4, or if you want, 2 1/4. It's up to you how you write this. But what we've done is we've found the equations of all of these lines. We found the area of this because we found the length of this line. We have found these coordinates. Our problem, such as it was, is solved, and errors and omissions accepted. Thank you very much for watching. My apologies about getting that coordinate wrong, and for any other lapses that I might have made. it's been a busy day, as they say. Thanks for watching. See you next time. Bye.